Hello, everyone. Today, we're going to talk about stoichiometry and solutions. But first, we're going to go over the homework to the molarity calculations problem. On problem number 1, you were given a certain amount of mass for potassium nitrate, and you were expected to calculate the concentration of a final solution, which would have a total volume of 500 milliliters. So to do this, the first thing that you needed to do was to figure out what the molar mass was for potassium nitrate. So I've done that here on the side. Next, we needed to convert from grams of potassium nitrate, which is right here, into moles of potassium nitrate using the molar mass. The molar mass in this case was 101.11 grams. Finally, once we had units of moles, so grams cross out, once we had units of moles, we could divide them by our volume to wind up with our concentration or molarity for the solution. In problems 4 and 5, we were asked how to prepare a certain concentration of a specific solution. So in this case, we also needed to begin by finding out the molar mass of our substance. So in our problem number 4, we had lead-2 nitrate. So if we look up the formula for lead-2 nitrate and we solve for molar mass, we'll get an answer of 331.22 grams per mole. In this case, we were making 250 milliliters of solution. So the first thing that you wanted to do was convert from milliliters to liters. Then, using the concentration that was provided in the problem, you wanted to convert from volume of solution into moles of substance that you would need in order to prepare that solution. So you're going to multiply by the molarity, which is in this step right here. And then finally, because we can't weigh out moles on a balance, we can only weigh out grams. The last step was to convert that number of moles into a mass in grams that would allow us to measure it out on a balance. And in the case of problem number 4, that turned out to be 165 grams of lead-2 nitrate. Same idea with problem number 5. So we're given a volume. We want to convert that volume from milliliters to liters. Then we're going to use the molarity, which is given to us in the problem as 3.25. We're going to break up that capital M. Remember, that has 2 parts, moles per liter. So in this case, 3.25 moles of calcium chloride per 1 liter. That will allow me to cross out liters. And then finally convert from moles back into grams. So we wind up with an answer for problem number 5 of 90.2 grams. So problems 7 and 8 on this assignment were a little bit easier. You did not have to calculate molar mass in order to answer the question here. So instead, we were given a number of moles. So if you look at problem number 7, we're starting off with 4.907 moles of aluminum oxide, and they tell us that we're dissolving it in enough water to make a 0.5 molar solution. And we just needed to figure out what volume of water would be necessary in order to finish with that concentration. So in this case, we're going to take the 4.907, we're going to divide it by the concentration, so 0.5 moles per liter. This time we're putting moles on the bottom, so it cancels out. So we wind up with 9.81 liters of solution. Now in the instructions, it asks for milliliters of solution. So in this case, we multiply our 9.81 liters by 1,000 to get 9,810. And we're going to do the same thing here. So to go from liters to milliliters, we would multiply by 1,000. Now in problem number 8, they started us off with grams. So because they started us off with grams, we now have to go from grams to moles before we can answer our question. So 0.783 grams of sodium carbonate must first be converted to moles. That gets rid of this unit of grams. Now multiplying by 1 liter over 0.05 moles of sodium carbonate, that'll get rid of the moles of sodium carbonate and leave us with liters of solution. Okay. I hope everyone did well on that assignment. If you have questions, please remember that we have office hours this week. Please stop by with any questions that you may have. At this point, honors and CCP students can log off the video. The rest of the video is intended only for students in the accelerated honors level. Okay, so let's take a look at our stoichiometry and solutions problem. We're going to start off with the first problem on the homework assignment, and then I'll allow you to do the other two problems on your own. So looking at our first problem, we have a chemical reaction here between potassium chloride and silver nitrate. It's going to produce a precipitate of silver chloride. That's over here. So before I even bother to read the question, the very first thing that I'm going to do is balance my chemical equation. Now, in this case, it's going to be a little bit easier than normal because all of my coefficients end up being ones. I have one potassium and one potassium, one chloride, one silver, one nitrate, which can be treated as one thing, and one nitrate on the right side. So all of my coefficients are ones. Now, if we go ahead and read the problem, it says a solution of potassium chloride is prepared by dissolving 75.0 grams. I'm just going to write down the information that we're given in the problem. 75.0 grams of potassium chloride in enough water to make 500 milliliters of solution. So these two things are going to combine to give us our solution. It says the solution is mixed with silver nitrate in order to form a precipitate. And then finally, what volume of potassium chloride solution, the solution that we have to prepare, what volume is required to form exactly 15.0 grams of silver chloride? So this is starting with our goal in mind. So we're going to start off this problem looking at the desired outcome, which is to make 15 grams of silver chloride. Then we're going to work backwards and figure out how much solution we will need in order to do that. So before we actually get to our stoichiometry part, let's talk about our potassium chloride solution. So in this problem, you're going to need to find the moles of potassium chloride in order to figure out the molarity of the solution. Because we need to figure out moles, and we're currently in units of grams, we're going to need to find the molar mass. So let's do that part first. Potassium has a molar mass from the periodic table of 39.10 grams per mole. Chloride off the periodic table has a molar mass of 35.45 grams per mole. So we wind up with a molar mass of 74.55 grams per mole. Excellent. Now, what we're going to do with that is we're going to convert the 75 grams of it that we have in our solution into moles so we can figure out the concentration of our solution. So I'm just going to identify this as part one. We're going to determine the concentration of the solution. And in this case, that solution is potassium chloride. So I'm going to start off here with my 75.0 grams. Use the molar mass that I just calculated in order to convert from grams into moles. So just doing a quick check on units, you're going to see that grams of potassium chloride and grams of potassium chloride cancel out. So in the next part, we're trying to get a concentration, which is in moles over liters. Right now, we have the mole part on top. We just need to divide by liters. So in this case, if we have 500 milliliters, that is equal to 0.500 liters. So to go from milliliters into liters, you divide by 1,000. So 500 divided by 1,000 is a half, or 0.5 liters. So on the bottom of our fraction, we're going to put 0.5 liters of solution. And now into our calculator, we're going to type 75 divided by 74.55 divided by, again, because it's on the bottom, 0.5 liters, and we'll get a solution with a concentration of 2.01. So there are two ways that you can represent this. You can say 2.01 moles of KCl per liter of solution, or more simply, 2.01 molar KCl with a capital M. So now we need to determine how much potassium chloride will be needed in order to make 15 grams of silver chloride. So I'm going to start a new line down here. It's going to be called how much KCl solution do I need? And in this case, as a reminder, we're going to start off with our silver chloride. So we are trying to make 15 grams of silver chloride. So because we are in units of grams, we can't really do anything until we move it into moles. So we're going to find the molar mass of silver chloride. At this point, most of you are very skilled at getting molar masses, so you don't have to show the work for getting molar masses anymore. So if I look up the molar mass for silver, that's 107.87. And then the molar mass for chloride is 35.45. So I have a total mass, or a molar mass, of 143.32. So 143.32 grams of silver chloride is equal to 1 mole of silver chloride. Please remember, when you are going between grams and moles, you always use 1 mole. The only time that you use something other than 1 mole is when you're changing from one substance to a different substance using the balanced equation, which is what we're going to do right now. So in our next step, I'll make this a different color so it stands out. We're going to convert from moles of silver chloride, which is down here. So I'll use a color that stands out. So we're going to take this one here, 1 mole silver chloride, and we're going to convert it to moles of potassium chloride. So that's kind of this one over here. Now, if this were a 3, then I would have a 3 on the top here next to moles of potassium chloride. If this was a 17, then I would have a 17 on top in terms of moles of potassium chloride. These numbers up here, the coefficients, don't change the fact that when I'm going between grams and moles, I always use 1 mole. So that part would remain the same. Okay, moving on. Let's take a look at our units. So we have grams of AgCl, that crosses out. We have moles of AgCl, that now crosses out. So now we're left with moles of potassium chloride. Well, in our problem, we're trying to find out a volume because we're dealing with a solution. So in this case, we're going to use the concentration that we made earlier over here in order to determine what volume we need. Now, notice that we have 2.01 moles of potassium chloride per 1 liter of solution. Because I want moles of potassium chloride to cancel out with moles of potassium chloride here, I'm going to flip this. So I'm going to have 1 liter of solution on top, and I'm going to have 2.01 moles of KCl on the bottom. Notice that my unit will cross out, so moles of KCl, and I'm left with a unit of liters of solution. So now I can type this into my calculator. So I have 15 divided by, because it's on the bottom, 143.32 times, and dividing by 1 does not change your answer, so don't waste your time typing that in. And then finally divided by 2.01. So I wind up with an answer of 0.05207. Now, the only thing that we have to do in order to complete this problem, two things. First, we have to look at our number of significant figures. So we have 3 significant figures here and 3 significant figures in 15.0. So we're going to limit our answer to just 3 significant figures. And the second part is, because they wanted, if you go back and look at the question, because they wanted the volume in milliliters, we have to take this number that is currently in liters and multiply it by 1,000. So if we multiply this number by 1,000, we get 52.1 liters of solution. So just a recap, when you're doing these problems, make sure you identify what the problem is asking for. So in this case, it was asking for us to find out how much potassium chloride would be needed in order to make this 15 grams of silver chloride. Start with what you're looking for, and then kind of work backwards to figure out what other information you need in order to get there. Units, if you notice, units throughout the entire problem. Units actually help you work your way through a problem because they tell you what needs to be canceled out, what should go on top and bottom. So units are extremely important when you're showing your work for these problems. All right, that's it. I would like you to complete problems 2 and 3 on your own. You can check your answers against the answer sheet that I have posted on Schoology. I hope everyone's having a great week. Thanks, everyone.